In this video, we're going to be going through the simplifying of square roots. And we're also going to use, in this one, the product property of square roots. Now before we begin, let's go over some information. Remember that a prime number is a number whose factors are only one in itself. So the numbers 2, 3, and 13 are examples of prime numbers because the only numbers that you can use to multiply to get them are 1 and itself, like 1 and 2, or 1 and 3, or 1 and 13. 24 is considered a composite number because not only does 1 times 24 equal 24, but 2 times 12 and some other numbers. Now when you have a square root, or an even root for that matter, there can't be a negative on the inside. If that happens, then your solution is really no real solution. Now let's head back to our product property. Now the product property of square root says that a square root of a product equals the product of the square roots of the factors. So what does that mean? Well, what it means is if you have the square root of 45, you can break that apart into the square root of 9 times 5, which then breaks apart into the square root of 9 times the square root of 5, which is 3 times 5. And our 3 comes from the square root of 9. So in algebra, we would say that's the square root of a times b, or the square root of a times the square root of b, where a and b are greater than or equal to 0. So if we were doing an example where we have the square root of 108, we would break that down and we could use a 9 and a 12. So here we could say that 108 is the square root of 9 times the square root of 12. We know that the square root of 9 is 3. And we know that 12 can actually be broken down into 4 and 3, which then gives us 3 times the square root of 4 times the square root of 3. And we know that the square root of 4 is 2. So we have 3 times 2 times the square root of 3, which gives us 6 radical 3 as our solution. Now another way that we could do this is by making a factor tree. So to make our factor tree, we could have used our 9 and our 12 here, and we could have broken down our 9 into prime numbers, so 3 and 3, and we could have broken down our 12 into a 4 and a 3, and then our 4 would break down into a 2 and a 2. So because we're doing a square root, we're looking for groups of 2. So here we have a group of 3's, and we have a group of 2's, but we have a lone 3 that doesn't have a partner. So we'll have a square root of 3 there. And that's going to give us a final answer of 6 radical 3. So notice that either way you do it, you get the same answer. Let's take a look at letter B. Here we have the square root of 9 times x to the third power. So what I like to do here is I like to make my factor tree for the 9 and get my 3's. And then for the x, what that really comes out to is an x times x times x. So I'm going to circle my prime number. So I have my 3 and 3 are both primes. And then each of the x's are primes because they can't get broken down anymore. And because we're doing a square root, we're looking for pairs. So I have a pair of 3's here, and I have a pair of x's there, with a lone x left, leaving me with a square root of x. So my final answer here would be 3x times the square root of x. And I would be finished. Now for letter C, we have negative square root of 80. So we're going to take a moment and just kind of ignore this negative sign for just a little bit. And we're going to break down our 80. So I'm going to use 5 and 16. Although you also could have used 8 and 10, and that also would have been fine. So let's use 8 and 10. Then we have 2 and 4, and 2 and 2. And we'll circle our prime numbers. We'll break down our 10 with a 2 and a 5. And because we're looking for square roots, we're looking for pairs. So we have a pair of 2's here, and a pair of 2's there. Notice that when I cross out a pair, only one of the numbers comes out. So, for example, when I cross off this pair, that brings down a 2. When I cross off this pair, That brings down that 2. And I'm left with my lone 5, so square root of 5. Now what we can't forget to do is we can't forget to bring down our negative sign. So this is going to come out to be a negative 4 times the square root of 5, and that's going to be our solution.